Objects in object-oriented programming are much more than just simple data abstractions. They add important abilities that you need for practical programming. So let's show how this works. We start with an object abstraction and we will extend it. So the first step is the object abstraction we saw before. So this gives us this simple ability of data abstraction. The second step now is, instead of having multiple procedures, we give the objects a single entry point. So we collapse all these procedures into one entry point. And we then, when we call the object, have to choose the method. This choice is done internally and it's called dispatch. The third step is we want to create multiple objects with the same methods but different states. For example, different counter objects. So to do this, we use instantiation. So the creation of the object is a function call that returns the object. So this is an example of higher order programming that we saw before. And the fourth step we'll see now is introducing specialized syntax. So we introduce a new concept called a class, which lets us define the attributes and the methods in our own special syntax. And we use this to create the object. So this gives us, in addition to improved readability, it gives us a guarantee that we're building the abstraction correctly. Since the syntax is checked, and behind the syntax, the system can build the abstraction. And finally, the system can improve the performance of the object by relying on the use of the syntax. So let's take the first step. So the first step is what we saw before. So here we have a simple object abstraction with internal state and the interface procedures. The example of this is the counter object here that we saw before. Okay, this counter object has all the advantages of data abstraction. In particular, it is guaranteed to be correct since we can only call it through inc and get. And there's no way to have a direct access to the internal cell. So that's the first step. The second step now is to give this data abstraction a single entry point. The single entry point, in fact, is a procedure, which we'll call counter, which has a single argument, and depending on this argument, we will execute one or the other method. So here the argument can be inc or get. And in order to choose the method inside the procedure, we use a case statement. So these arguments are in fact records, and they will choose the right procedure using the case inside. Since the entry point is in fact a procedure, this is called procedure dispatch. The dispatch is the process of choosing the method that corresponds to the argument. And the argument is usually called a message. Okay? So this is the second step, single entry point. The third step is maybe we want to create multiple objects with the same methods but different states. Here we have a function new counter, and each time we call new counter, it creates a new object with the same methods but with a different cell, different state. And this is an example of instantiation since we're returning an anonymous procedure. So this is a kind of higher order programming that we saw before. So each of these new objects is completely independent of the others because the state is independent. So here's an example. We create one new object here, C1. We create a second new object, C2. And here we will increment the first object twice, C1 inc, C1 inc. And now if we display the state, we have local x in C1 get x. This one will show 2, which is the internal state of C1. And local x in C2 get x will show 0 since we have not touched the state of C2. We've only incremented C1. The two objects are independent. The fourth step that I want to show now is the introduction of a specialized syntax. Here we introduce a new syntax, a syntax based on a new concept called a class. Here we introduce new keywords here, class, attribute, method. We have the name here. We're declaring class counter with attribute A, and each of the methods here has its own method declaration with the name of the method here and the attributes here in instructions in the body of the method. Notice that in this particular syntax, the attribute is an atom, and the use of the attribute, it looks like a cell, except that it's an atom. Okay, so this definition is called a class, and the reason it's called a class is because we say that all the objects it creates have the same behavior, so they are of the same class. So it's reusing an everyday term. Notice that in this particular way we do it, the creation of the object is done independently of the creation of the class. We have a function called new, which when we give it the class as an argument, will create a new object of that class. So we have in fact separated the object definition from the object creation. Okay, and the fact of having this new class syntax gives three important advantages. First of all, it guarantees that the abstraction is constructed without error. This syntax corresponds to the definition we had before, and the system will automatically translate it. It also improves readability because it introduces concepts at the level of objects and not the lower level concepts of procedures and cells. And also it lets the system improve performance. Maybe the system can find a way of implementing this class which is more efficient than the direct way using cells and procedures.